Okay. So this week we are going to cover route selection and highway design intro, part 1. Okay. At the end of this class, I will provide you a link to a YouTube channel. Then you can watch. I have given an example of how the actual route selection is being done. For that segment, you'll need to look at spectrum. Under the Arahan Teknik Jalan segment, there are 3 PDF documents. Design example part 1, design example part 2, and design example part 3. Okay, those 3 documents you're going to need in order for you to understand that video, because I'll be using that document in the video lah. Okay, please have it handy for you to use it as a reference. Alright, so the basic principle for highway is that roadway elements such as curvature and grade must blend with each other to produce system that provide easy flow of traffic. Okay, so the curvature, you must have a harmonious blend of the features of the highway. Okay, such as straight lines, curvatures, tangents, and the gradients. Okay, it must be in harmony. All right, to create a system that is will be easy for the traffic and also be safe lah. Okay, so in locating the highway, there are four main phases. Okay, depth study, recon survey, prelim survey, and final location survey. So this is summarized in this diagram lah. Depth study, recon, prelim, and final location survey. Depth study is just examining documents lah and maps. From that, you can select feasible roads from the maps. Okay, probably. So you'll be given a general topographical map of that area. Okay. Let's go one by one here lah. Okay, for depth study. So depth study of area, you'll need to review all the relevant design, field, and planning data. Okay, you get maps, aerial photo, charts, and photograph. Nowadays, I think probably it's not popular lah anymore, aerial photograph. You will have LiDAR data. Okay, I'll show you some example of LiDAR data lah afterwards. And then the source of data, engineering data, whether it is traffic data, okay, demand data, and then you have environment data, whether the area has resources, the type of topography and all that lah. Social, if there are houses in that area, economic data, what are the economic activities and in that area. Okay, engineering data, topographic and geological maps. So you need to know the resources if there is any. Stream and drainage basin, very important to make sure that you don't have your road lying in the flood basin. Okay, climatic records. This is from Jabatan Kaji Cuaca lah kot. Kan? So you get the amount of rain that area experience. And also prelim survey of previous projects that is nearby. Okay, for example, your road is just close by to another road, so you have the maps for that road available, so you need those data. And also you have traffic survey and capacity studies. This is mainly for new roads in urban areas lah. Okay, that you have studied the capacity and the traffic survey, the demand and everything. So environment data is the agricultural soil survey, indicating soil erodibility, noise studies, okay, wildlife inventories, and historical studies. I was told that one of the roads in Kedah, near Sungai Batu, that road lies directly within the area of apa tu archaeological punya digging study, archaeological study. But at that time, during the time of the design, they do not know the condition of that area. So that results in the road is being built on top of the excavation site. That is currently under in the interest lah of Jabatan Warisan. So once the road is there, then is apa tu goodbye lah. Okay. So you need to take into account all of those things. Historical. Social data, okay, demographic and land use information, zoning plans and trends. This one I've shown you just last week lah kan. Kat mana dia punya zones and the demographic of the people living there. Economic data, overall cost of previous projects. Okay, what is the cost? Unit construction cost data, agricultural, economical, and industrial data, and then property values. Okay, so this, especially the overall cost of previous project that is nearby lah, not previous project in Zambia. Okay, so that can be used to estimate the rough. You have a rough idea what the price of the project is going to be. Okay, even though this sounds simple, it includes apa tu? You need a lot of data and manpower to gather all this data and study, because this is the point. If you get this starting point wrong, it will impact the entire project. There is a project that is being undertaken by a Malaysian company in the Middle East. I don't know whether this is apa tu, urban legend or something like that, but I got it from quite a reliable source lah. They mentioned that this company went to the Middle East. They've been awarded a contract to construct a highway. And at the beginning phase, all of the top guns of the company go and have a site visit and all that lah. But unfortunately, the top guns do not play their role well. Okay, they just go there and think that, oh, this is just a desert. It's apa tu? It's easy to construct a road. Okay, they didn't even bother to check the geological data. Okay, once construction started, they have the maps and everything, the design plans or everything ready. Once construction started, they found that that area they have formation of rocks, okay, not too deep underneath the surface. Okay, so okay, they say never mind, we'll blast these rocks lah. But then they found out that the government does not allow any blasting, because near that the area of the highway, it is very close to some oil wells. This is where I'm not sure lah, whether in the Middle East their oil wells is in the desert or not. Okay, because of what I know is that their wells mainly are in the sea, isn't it? But they say that in this country they have oil wells on land lah, inland. All right, they do not allow blasting. They say, oh, okay, never mind. So we'll ship our machineries from Malaysia to apa ni? To break all the stones, okay, the rocks. They say that they do not allow this. The government do not allow this. They say if you want to use machineries, you must hire machineries from our country. We do not allow foreign machineries to be imported into this country to do our job. So they end up having to hire machineries from that country, and this costs them lots of money. And for that project, they actually lose money for the entire project just because of this mistake. Okay. So this is where the first part of the job is very important. Doesn't mean that if you are a higher top gun of a company, you can go and just play golf, okay, with the sheikh and everybody. Okay, you need to do some job lah, some work. Okay. All right. Before a road can be located and designed satisfactorily, you need to know the purpose of the road. Okay, the population, like I mentioned last week, whether it is going to cross over kampung area, villages, and then you need to know the alternative routes available, volume and composition of traffic. Okay, if you are doing a road uh, in rural area, the volume and composition is going to be different if you're going to construct a road near Port Klang, for example. Okay, you can go right now to any road near Port Klang, you can see that the volume of trailers, large trucks are very high. Okay, and then you need to know the trend developments after opening a new road and estimate the rate of development and increase in traffic. But the rate of development, okay, this normally we estimate from the RTVM, okay, because they have already given us the percentage. Okay, feasible routes are identified by taking into consideration the following: traffic surveys for population and industrial areas. Okay, 1 minute. Okay, and then directness of route. Okay, are you going to have a road that is straightforward? Okay, point A to point B, or you can to have lots of curves, something like that. Okay, and then the terrain conditions, swampy ground. For example, elite highway from Shah Alam to Nilai, isn't it? Okay, the main part, major part of that highway is lies across swampy ground. Okay, so the soil the soil improvement in that area is very expensive. Okay, and avoid environmental sensitive areas. Okay, places of worship. Okay, burial ground and all that, and reserve. But normally, this is not a problem lah. Places of worship, definitely you need to be careful. Terrain and soil conditions, swampy ground. Okay, sama ini tadi. Cut and fill balance. Okay, this I will explain to you. I think I already explained in the video how to the balancing the cut and fill. This is for next week actually. Okay, crossing of other transportation facilities, okay, river crossing or railroads and highways. Alright, if you can avoid crossing, then meaning that you save a lot of money lah. Isn't it? You don't have to build a bridge, or you don't have to build a flyover. Alright. To amplify and verify condition. Okay. Determine from preliminary study by making a survey along the path selected on the map. So this is actual survey lah. Okay. Making a survey along the path of selected on the map. But not really the bukan detail sangat, tapi still this is land survey. Alright, so this is available in two methods, either ground survey or remote sensing. Ground survey is for small and medium projects, because at this level, recon survey, it is not very cost economical for you to conduct ground survey for a large project. Okay, if it is small and medium, then it's okay, because it's not too difficult to carry out. Okay, so these are the things that you use lah, total sessions. Okay, I've seen you conduct the survey last week. I'm wondering, are you still having survey subjects in final year, or is it the last survey is in the third year, isn't it?
It was survey camp, doctor.
Oh, survey camp. No
Yeah.
wonder. Okay. Thank you. All right. So this is for using ground survey in the recon part. Okay, just a broad simple survey. But if it is a big project, you need to use remote sensing. Okay, aerial photography or LiDAR. Okay, so this is for larger project lah. So it is easier to obtain proper horizontal and vertical control, adaptable to computer application, reduce the amount of ground control work, substantial saving in time and money. Okay, if you have the data available lah. So LiDAR is, you get the data from, you have a plane flying, or some people say it is from a satellite, isn't it? So that kind of data, they can distinguish the height of the terrain. Okay, so the red one is the highest area, and then it reduces until the blue one. So from here, they can estimate the topography, the contour of the terrain. Okay. All right. Study alternative alignment. So you need to examine the features: safety, road user cost, construction cost, maintenance cost. So every alignment that you suggest will have different capacity, different user cost, and construction cost. This is why in your project, I have asked you to construct two options. Okay, two options. If you can have three, then it's okay lah. You pun boleh letak three. Minimum two. Minimum two. So those two design is going to have quite significant difference in terms of construction cost. Okay, and then you also can have difference in maintenance cost. To estimate road user cost, you need some sort of economic study lah. Okay, to calculate the amount of fuel, the amount of petrol. Normally, for road user cost, the cost comes from if the gradient is too steep. Okay, commercial vehicles will have to use extra amount of petrol to climb the hill. Okay, another road user cost if that road cost lots of accidents. And that is also a cost. Okay, next is in studying the alternative alignment, you can carry out environmental impact assessment. Okay, due to this location of families, farms, and business. This is also a must, but this is not within my territory. I think the specialist in AIA is Dr. On. Okay, because we used to have environmental engineering course in our department, but that course has been closed. Okay, discontinued lah. In that course, they learn how to conduct this environmental impact assessment. Undertake traffic studies. This is normal lah that I've mentioned last week, and provide scenic and aesthetic enhancements of the area. Okay, so you need to compare until up to this point lah, scenic and aesthetic. Sometimes the road is longer, but because the path that the road takes is scenic and more aesthetic, okay, so the ministry will opt for that one lah, okay, just for tourism. Okay, so this is the simple rules lah in selecting alternative alignment. So start with reasonable economy. Minimum requirement regarding curvature and grades. The more curvature you have, the higher the gradient that you have, the costly, the more expensive your road is going to be. Okay, so you need to produce an easy riding, free flow traffic artery that has high capacity and meets all safety standards. Actually, this is number one lah, safety. And safety is number one. Okay, the location survey should recognize and evaluate the route's impact on existing industries, business, and residential areas. I'll show you one map to highlight this point afterwards. So the resulting route, after comparison of several alternative design, the route selected is the one that has the cheapest cost, Okay, considering the capital investment, maintenance expense, and savings to the road users. Okay, so safety is number one lah. If you ask me, safety is number one. Next comes the economy. Okay, the cheapest road is a straight road that has no cut or fill. Again, but that is close to impossible lah, unless you are working maybe in the middle of American Midwest, for example. Then they can have a very straight road. However, bear in mind, actually in our country, we do not allow a road to be straight for more than, I think it's about 1 or 2 kilometers. You cannot have a road that is completely straight for more than that length. This is because people tend to get sleepy, okay, and apa tu? Because it's very easy driving, straight roads, okay, so people will get sleepy and it will impose danger lah, okay, higher risk actually for the drivers. Okay. Alright, so this is area photograph lah. Prelim location survey serve as basis for fixing the actual highway location after the preferred location has been established. After that, then you can get the produce base map, okay, where the scale is 1 to 50,000 and 1 to 12,500. Okay, so this will give complete information on the topography, land use, and all that. All right, but the best way if you can actually go to the site lah, if it is not a forest. Yeah. If it is going through Taman Negara, then you'll need this kind of information lah, aerial photography, LiDAR, and all that. But still, when you get the rough alignment ready, you need to go to rekey where the site is. Okay, final alignment. So it involves trial and error process. You will know this very well when you conduct your project, very well, because you need to change. Once you change the alignment, the horizontal alignment, the vertical alignment is going to change. So that requires great skill and judgment. So from there, you will compute horizontal and vertical alignment that gives smooth, consistent alignment that satisfies the grade, curvature, cross section. Okay, this will make more sense when you start doing the project. This sentence here. All right. So identify tangent length, transition spirals, and simple and compound curve. All right. I'll explain to you this later. Okay. And the final location survey, you permanently establish the center line. This is the actual selected alignment. So you need to collect necessary information for plans. Again, you collect information again. Confirm major and minor control points on the alignment that was previously determined. Control points meaning that where it starts, where is the important junctions, okay, where is the intersections, intersection point, okay, for example, these points. You have this curve. This curve will have an intersection point somewhere here. This curve will have an intersection point somewhere here. All these are control points. So, okay. Provide direction to all property lines, distance to property corners, location of buildings, and all that. Okay, tak apa, lepas ni saya akan tunjuk dengan you property lines ni. Tangent points ni pun saya akan tunjuk dekat you. Okay. Make a new profile and accurate cross section from which excavation and embankment can be measured. Okay. So in other words, you will construct these things. Alignment, you get the topography, terrain, benchmark levels, cross sections, corner ties and other land ties and drainage utilities. Okay, this part for the time being we do not cover in our course. Okay, so the scale is, this is suggested lah, 1 to 1000. So for the details 1 to 500 and 1 to 50. Okay, please bear in mind in your project the scale is 1 to 1000. Okay, in the example I'm going to show you afterwards in the video, the scale is 1 to 1500, 1 to 500. Okay, don't have that thing mixed up. Okay, so this is the example of the construction plan. This is the horizontal alignment, which is a plan, meaning that you are looking at the road from above. Okay, so this is more or less straight segment, corner to the right, corner to the left, corner to the right, something like that. Okay, and this is the vertical alignment. It means that you slice this road in the middle segment here, and then you plot the ni actually tak jelas lah gambar ni. Okay, first you will plot the natural terrain, and then you plot the design terrain. So what you have here is actually, I think this is the natural terrain. Saya tak nampak scale, tak tahu lah. Okay, so sorry, this is not a natural terrain, this is the design terrain, meaning that the height along this road is like so. So this is going downhill and going uphill. So for every point here, it corresponds to the next point on this plan. So meaning that at this point you are driving, going downhill. Okay. So from here you start to go uphill. It's like that. Okay. So if you look at this plan over here, if you slice this way, if you slice this road this way, and look at the width of the road, you will see this. Okay. So this is the cross section. The grey line here is the natural terrain, existing terrain lah. And the dark line here is your design. So you can see here, so this is the car driving towards us. This part is cut. Okay, and this part here is fill. In this case here, this is the natural terrain, and the entire segment of this road is fill. Okay, so for every road, maybe in every 10-20 meters, they need to slice the road for the entire length of the road, and they need to produce cross-sections plan, cross-section diagrams. This will show you where your road is and whether it is involving cut or fill. Okay, you'll get a better picture when you start doing the project. Okay, factors affecting highway location in urban areas. This is, okay, I think I already explained this last week, kan? Trip, orientation and purpose, land use, parkings, other transportation systems. Okay, if that road leads to let's say MRT station, then the pattern is going to be different lah. Topography and geology, sociology and all this. This is repetitive. Land use pun sama. Okay, tak apa. Alright, kita tengok kat sini lah. So this is the summary, route selection best practices. This is not a must, but it's a good thing to pay attention to lah. If you need to cross river, try to cross it perpendicularly. You can have an angle, but bridge that cross rivers perpendicularly is going to be shorter lah, kan? Okay. However, if the bridge or viaduct alignment is curved, then the bridge or viaduct should be curved accordingly lah. Meaning that you can cross the river with a curving bridge. Okay. Avoid crossing railway lines at grades. Okay. At the current time kita dah tak buat dah ni, zaman dulu je lah. Kan? They cross tu at the same level at the railway lines. Nowadays, if you want to cross railway line, you need to construct flyovers. Highway should transverse the edge of properties, hence avoid splitting the community or the land plot lah. In the context of agricultural plot, this practice avoids creating small land parcels that may not be feasible and economical to cultivate. This is the example. This I got the lot plans I get from UPEM. You can go to UPEM website, Jabatan Ukur dan Pemetaan Malaysia. You can actually look at this type of maps lah. Okay, so this is in Segamat Johor. All these numbers are plots, land plots. Okay, if you zoom in, this is a plot that's highlighted in green, and this is the lot. And this lot here is this one. So this is the road. So you can see here, over here, it crossed nicely along the boundary. But when it comes to this plot, it cuts some amount lah of the land. So this splits this lot into two. Okay. In this case, the owner of this lot actually allows the road to cross his land because the size on this part is still big enough. Maybe the owner thinks that if this road here becomes larger and people start to construct shop house, so his land will have two front facing the road, isn't it? This one facing the road, this side also facing the road. If it is too small, then it becomes unviable for this plot. So you need to make sure. Here is even worse lah. They cross tengah-tengah. So it depends on the owner. You still need to pay them compensation because you are taking their land to construct your road. But the second issue is splitting their land. If they allow to split their land like this, then it's okay. Okay. So this is the road, and this is the road in aerial photo. Okay. So ini kat sini lah yang split dua ni. This lot. This one. Kenapa saya letak gambar ni, saya pun tak ingat. Tak apalah. Okay. I hope this picture will show you, give you some idea lah. Guys, boleh stop sekejap tak? Sebab saya punya tekak unusually dry lah tu ni. Berapa minit? 5 minutes ke 10 minutes?
Both okay.
Okay. Okay. Sekarang ni 11.1, 10 minutes lah. We'll start in 11.10.
Okay, Doktor.
Baik, Doktor.
Okay. Okay, I'm back. Thank you very much, everybody. Let's continue our session. Okay. Best practices. For highways traversing mountainous areas, watch out for possibilities of landslides and slope failure. Okay, meaning that you need to avoid areas where the soil condition is not good. For slopes, okay, it's very important, not just the angle of the slope, but the type of soil. If the soil is weak, the angle of the slope uh, cannot be at a minimum. Okay, if the type of soil is very cohesive, very good soil, then probably you can go for maximum steepness of the slope. This is for the side slope. Okay, avoid areas with shallow rocks. So this is the problem where the Malaysian company that is being experienced by Malaysian company. Underneath the desert sand are very shallow rocks. Although shallow rocks provide good rock foundations, but earthworks in form of cuttings may be difficult to execute. So they need to blast. So they cannot blast, they need to drill. So that's a very expensive process. Consider the availability of construction materials for road buildings in the neighborhood of project site to minimize transportation costs. Because roads normally will require cut and fill. Okay, the best solution is you cut from one place and use that material to fill, okay, in the next available site. However, some site you only require fill, meaning that you need excess soil. So make sure that the alignment crosses a place where it is easy for you to get access to extra materials. Meaning that the landowner say, okay, my land here has a hill. So you can excavate the hill, take the soil and put it as fill material in your highway. Okay, this is the explanation lah. Highway should not pass through ecologically or environmentally sensitive areas, include national parks, areas enriched in wildlife or scenic natural beauty. This is exactly the opposite what I've shown you last week. Okay, so the road that is being proposed indeed goes through national parks and areas rich in wildlife. Okay, there's always an exception. It's like P. Ramlee punya cakap lah. Ini undang-undang kena bikin, semua boleh padam punya. Okay. Choose route on higher ground and avoid areas prone to flooding. Okay, this is very important. Some areas does not get flooded very frequent, but if you consider a longer analysis period for your flooding analysis, maybe 200 years, that area can be flooded. So you need to choose correctly what is the analysis period that is required for your project. Okay. Choose a route, samalah route ke route. Cutting and filling not only minimize but balance. Okay, meaning you cut one from one place and fill it in another place. If geotechnically sound, the material will be used as embankment in fields, meaning that what I've said just now lah. The same material from your site you use as your embankment filling. This will minimize visual intrusion. Okay. Disposal of unwanted cut materials can harm the environment, meaning that you have lots of cuts, don't know where to put. You end up dumping the soil elsewhere. So it can be harmful to the environment. Unless you have people to buy lah. Some people they say, okay, my land is very low, so I need some material to fill in a segment of my land. Then you can sell the earth to that person. Okay, aware the location site of junctions from the perspective of traffic safety. This is relevant in urban areas. Okay, you need to look at the junction as a driver lah, meaning that you have to go there and observe the characteristic of that area. The location of some junctions can be undesirable from traffic safety viewpoint. Example is a hidden junction located at a sharp corner after the peak of a summit curve. I have a diagram here afterwards. Meaning that you cannot see. You are climbing a hill, you cannot see what's in front of you. Okay, suddenly when you just about to go downhill, there's a junction just beneath of that summit curve. Okay, this need to be avoided. All right, consider the presence of underground utilities, electricity cables and all this. So this is very important where you get the source of your survey map. There's one project that I've worked with. The survey map is very unreliable. Okay, when I go for site survey, I notice that there's a gas pipe that is not being marked in the survey map. This is very big problem. Okay, I went back to the office and thought, inform my boss lah about this. His face immediately changed because this is gas pipe, not just some simple water pipe. Okay. Fortunately, when we actually conduct the actual survey, that gas pipe is outside from our construction area lah. We do not need to change anything. That is very lucky. Okay. There is one incident actually when I went in the same project. There is a temple. I don't know, like I just going there to ask questions at the people in the temple, and they say that I don't know. Maybe our Indian friends can inform us further about this. I asked them. There is a macam I cannot explain it. It's like a place lah. Okay, I just asked them what is there. Okay, and the priest tell me that is a snake. The place for the snakes. Oh, okay. So where are the snakes? And the priest told me that, oh, at this time the snakes went out and look around. I betul-betul terperanjat kata, betul ke? Mana cepat-cepat kami pun okay lah, goodbye. I just tanya apa yang perlu and then say goodbye. I don't know. And then I starting to wonder lah when I'm in the car. Jangan-jangan dia saya saja buat kelakar ke dengan saya. Memang saya funny things lah. I tak pandai buat joke lah. Tapi that's one thing that happens to me lah and my friend. Okay. Yes, somebody wants to say something?
Nothing, Doctor. You're funny.
Mana? Okay. Changes in road alignment and creation of access road that traverse the utility area would require their relocation. Okay, ni memang kita nak avoid lah. Kadang-kadang some relocation of utilities can be very costly. Memang bukan can be very costly. It is costly. Okay. Kadang-kadang sometimes even authorities. One example, I don't have the picture lah. One example is in Kajang. They have designed the alignment in such a way where they need to enlarge widen the road lah. They design the road in such a way that they avoid relocating the light post in the middle of the road. realistically, they need to realign the lighting post because the alignment of the road has changed. Okay, but they avoid doing that. So the alignment you can see is actually a little bit funny. It's a little bit funny. Okay. So this is the result of when we don't have enough money to relocate the utilities. All right. Projection of traffic. New roads improvement should be based on future traffic expected. For normal road, the usual design period is 20 years. Okay. Although you can have your pavement construction based on 10-year period, meaning that you design your road for 20 years, but pavement in stages lah. First stage 10 years, second stage another 10 years. So this is the design vehicle. You have passenger car, single truck combination. Okay. For all roads that is being used for majority of the vehicles lah kan, kita akan gunakan truck combination WB15. You cannot design your road only to cater for passenger cars or single truck. If you only design your road for passenger cars, single truck cannot use that road. Okay, if you design using this WB15, meaning that all this will be covered. Okay, this is because the dimensions of the vehicles. Okay, the most important part is this turning radius, meaning that the radius of the curve. All right, for cars, the turning radius is just 7 meters, 7.26 meters. And then the truck combination is 13. So you provide the turning radius 13.72 minimum, so everything will be catered lah. So this is the example of the diagram. This is the passenger car, this is for SU, and this is for trailers, WB15. Okay. You need to take into account the path of overhang here. Okay, you have several radius over here. Okay, CTR, centerline turning radius is here. But you need to provide extra area for path of overhang. Okay, when you take a corner, you can see here, there's an overhang area between the tire and the edge of the vehicle. And here from the tire and the edge of the truck. So you need to consider this radius, not just the centerline radius. Similarly, for trucks, trailers, you need to consider this one. Okay, 13.93. It's best if you can provide 50 meters so that the truck can have a U-turn. Okay, so these are some example of terminology lah. Posted speed, okay, which is the speed limit. This is the speed that you see on the signboards. Operating speed, which is the free flow speed, meaning that if you go take the spot speed along the highway, okay, and then you average it up, so that is the operating speed lah. Running speed is the length of highway divided by running time. This is not important. And then design speed, selected speed used to determine geometric design features. Okay, so this is the speed that you use to design your road. Okay, mana tadi? Okay, so design speed is the maximum safe speed that can be maintained over a specified section of a highway when conditions are so favorable that the design features of the highway govern. Design speed should be consistent with what the speed the driver is likely to expect. Okay, this is actually related with what the term of speed environment. Okay, the geometric features of your road will determine the speed of the drivers, isn't it? If you construct a highway, the width of the lane is 3.7 meters, for example, very wide. There is no obstruction along the highway. The road is straight. Can you expect the drivers to drive at 70 kilometers per hour? Almost all drivers will go faster than that. Okay, so because the environment is very conducive for speeding. So you need to consider the type of road that you want to design, and what is the behavior of the drivers. You need to expect the behavior of the drivers when you use that geometric parameters. So the design speed will also fit the travel desires and habits of nearly all drivers. Nearly, not all drivers, because it is impossible for you to cater for everybody. What it means numerically for nearly is 85%. Okay? If you design a road, let's say the design speed is 100, it means that 85% of the people will obey, will use the road within that area. 15% will be the crazy ones. That 15% we do not take into account. Okay, those are the people that will go 120 or 130, where the speed limit is maybe 90. Okay. All right. So design speed is not posted speed. Okay? What you see on the signboard is not the design speed, and it's also not operating speed. But design speed will always be higher than both. Okay. So if you design a road at 100 kilometer per hour, the posted speed is going to be maybe 80 kilometers per hour. Okay, that's why you see normally when you are driving at a curve, at the corners, the design speed, the posted speed is 80, but you see you still can drive around 90, 100. You still feel safe. Okay, taking that corner. Okay. Design speed considerations, functional classification of the highway, character of the train. Ni semua dah cerita lah. Okay, same thing. So this is the design speed recommended by Arahan Teknik Jalan. So you have design standard R1 to R6, design speed, okay, according to the terrain, flat, rolling, and mountainous. Okay, so you can choose from here. All right, so how to differentiate what is flat, what is rolling, and what is mountainous? So I've shown you the cross-section diagram before. If the existing terrain here, the average slope of the existing terrain is less than 3%, so it is considered as flat. If the existing terrain, okay, the slope here is 3 to 25, okay, it is rolling. More than 25, it is mountainous. So this is for rural segment. Next is for urban. You have area type 1, 2, and 3. Recall from last week, the table that I show you. For urban, they use flat, mountainous, and rolling and mountainous, isn't it? So this is where I think that table, there's a mistake there. Okay, for urban, it should be area type 1, area type 2, and 3. Where type 1, the road locations has very little problems regarding land acquisition, meaning that it does not cross sensitive areas. Type 2, it is intermediate between 1 and 3, and type 3 is very restrictive. Okay, meaning that you have land acquisition, affected buildings, and other sensitive areas. Okay, this is up to you to decide lah, whether it is type 1, 2, or 3. Next is the alignment design. You have two alignment types. First is vertical alignment, horizontal alignment, and then you have vertical alignment here. Horizontal alignment is the view of the road from above, meaning that it is the plan. So you are traveling here, corner to the left, corner to the right. But in the engineering terms, we call this as curves, horizontal curves. And this is the vertical alignment. This red line shows the existing terrain. Okay. And this, sorry, these lines here show you the design terrain. So you start with a straight line going up, straight line going down, straight line going up. So this segment is cut segment, and this is fill. This is cut, a little bit of fill over here, cut and fill. Okay. Next, you have super elevation, cross section, widening, and intersection. Okay, we'll go with one by one. So horizontal alignment. Okay, so this is horizontal alignment. The way you start designing the alignment is start with, similar with the other diagram, you start with straight lines. In this case, it's this green line. Let's say you want to connect one point from here, another point from here. Okay, you can go straight if there is no problems. Okay, but most of the time you cannot go straight line. Okay, necessary for gradual change in direction. So you need to go going up and then going down and then going up. Not up lah, ni plan tau. Okay, going to the left, going to the right, going to the left. All right. Next, you fit in the red line, red curve here. So this is the circular curve part of the corner. This is the circular curve. And the blue line here, the blue curve here is a spiral. It is not a circular curve. It is a part of a spiral. Okay, I'll explain to you later. So the objective is for you to obtain safety and comfort. Okay, transition between two directions. Okay, you have circular curve, you have transition curves. Transition curve, this is the spiral that I mentioned just now lah. Okay, so these are the types of horizontal curves. You can have one simple circular curve, and here is a reverse curve. We try to avoid using reverse curve. And this is compound curve, which can be quite dangerous juga, because the radius is different. From here to here is different. And this is the best one, meaning that from a straight line, you enter a spiral part, and then you enter the circular part, and then the spiral part again, and then straight line. Or you can combine like this, two circular arcs combined with straight road segment. Okay. So horizontal curve consists of tangents, circular curves, and possibly transition curves. So straight line, circular, straight line. This is a simple curve. Tak ada spiral. And here, you tengok ada straight line, ada spiral, which is the transition curve, and then you have circular curve, transition curve, straight, semula. So you have 4 points. TS. Tangent to spiral. Okay. And then SC, you have spiral to circular. And then CS, circular to spiral. And then ST, spiral to tangent. Okay. Why do you need spiral? So I'll just draw a simple diagram here lah. If you zoom in when you're drawing with AutoCAD lah, you have a curve. And this red line is the tangent. When you zoom in, this red line is actually not joining with the black line, the curve, isn't it? So you need another blue line here to connect this circular curve with this red line. So this blue line is the transition curve, which is a spiral lah, part of a spiral. Okay, but for very large radius, let's say your radius is 1 kilometer or more, there's a range for that, I forgot. Okay, this is just an example lah. The radius is 1 kilometer. You do not need spiral curve because the connection is not significant anymore. If the radius of this curve is very small, let's say 50 meters or less, you also don't need spiral because the road is very small, the transition is not important anymore. So spiral transition curves are used where there is a range. The radius of the curve is within a specific range. If it is too big, you don't need transition curve. If it is too small, you do not need transition curve. Large curves, it will seem to you that you are driving on a straight. Okay, so it is the transition does not play any role anymore. 1 kilometer radius, you do not feel that you are actually driving on a curve. Okay, so this is the minimum radius. Okay, design speed, and these are the minimum radius that is corresponding to different E. This E value is the super elevation rate. Okay, I'll explain to you afterwards. Super elevation rate. Or you can use this formula to calculate the minimum radius, where you need the super elevation value and you'll need this F value, which is the side friction. Okay. Apa ya? Ini vertical alignment, I dah tunjuk tadi kan. Okay, so you are going uphill and downhill. So this red line here is your design alignment, vertical alignment, and the yellow one is the existing terrain. So this red line can be shown as several straight lines. So you see here, positive 4.17% going up, and then here negative 1.57 going down, and positive 1.55 going up. Okay. So this is going up and down, no longer going left and right, up and down, z-axis. All right, so if you look here, point 1, 2, 3, and 4, this is point 1, 2, 3, and 4. So you're going down, so the G1, the gradient, is negative 4.8% going down, and then positive going up here is 3.2%. So this is the curvature. All right, in this diagram, it is shown here as curve length 550 feet equals to 5.5 station. Please ignore this designation because this is American way of marking the stations. Okay, they mark their station. We also use the word station, but the way they use it is different. Okay, this is where you need to be careful when you are using American books, where one station is 100 feet. Okay, in their way of calculating. We normally we say chainage lah, just meter. Okay, chainage 1 plus 500, chainage 1 plus 700, something like that. I'll explain to you later lah what that the way we measure our road. So these are the examples of equal tangent vertical curves. So positive and negative, Okay, positive G1, negative G2. So this is for crest vertical curve. It is a crest. Or you can have positive and positive, like so, and negative, but it is still a crest vertical curve. Another type is the sag vertical curve, where you have negative and positive, or negative and positive. So it depends on the difference between G1 and G2. So to calculate the length of vertical curves, you'll use this formula. L equals Ka. K is the rate of change of the slope, the rate of change of the length along the slope. Okay. Okay, the curve length for a slope change of 1%. So it shows you the abruptness of the grade change. Okay, when A is positive, vertical curve is a crest curve. So to calculate A here, you use this formula. Okay, so A equals P minus negative Q. See, this is positive P minus negative Q over here. All right. So when A is negative positive, it is a crest curve. When A is negative, the curve is a sag curve. So this is the value of K given in the arahan technique. Okay, minimum value of K for crest vertical curve and sag vertical curve. Okay, next is the combination between horizontal and vertical. Okay, so you need to balance the use of horizontal and vertical curve. Okay, sharp horizontal curve not at bottom of steep grade, and sharp horizontal curve should not be introduced near the top of a pronounced vertical curve. Meaning that you naik bukit, suddenly dekat atas bukit tu ada corner. Then you are climbing a hill, climbing a hill, and then at the top of the hill there's a corner. Meaning you cannot see. When you're climbing up, you cannot see there's a corner on top of the hill. You need to avoid that. This part is horizontal curve at the bottom of steep grade. Going down, at the bottom of the gradient, there's a very sharp corner, sharp curvature. Okay, avoid excessive curvature to achieve flat grades. Maksudnya, if you want to design your vertical alignment to be as flat as possible, but to achieve that, you need to design it using excessive curvature, horizontal alignment. Or you use excessive grade to achieve a flat curvature. I think this will be very clear when you start doing the project lah. Okay, you want to achieve a flat curvature, meaning that you do not want to use any corners lah. You want to go straight. In order for you to do that, you need to climb very steep hills, for example. Okay, you need to balance between the horizontal and vertical alignment. So it should be consistent with the topography, preserve developed properties along the road. Okay, this is what I mentioned just now lah, my visit to the temple just now, because we need to preserve. Kan, kita tak mau langgar lah, kita tak mau ada land acquisition dekat kawasan tu. Memang luckily lah, macam this is the same day on yang gas pipe punya visit tau. I tengok gas pipe, and the same day we visit the temple just to look at the boundary. So we need to preserve as much as possible. Okay, develop properties along the road. Follow natural contour of the land, if possible lah, if the contour is mild. Okay. Intersections where side distance need to be accommodated, both horizontal and vertical curve should be. Alamak. Sekejap. I kena stop sekejap lah, boss call. Sorry ya. Okay guys, sorry. Ada urgent phone call. Okay, dekat mana tadi? Okay, preservation. Okay, lepas tu, does not affect aesthetic, scenic, historical and all this lah. Again, try to preserve natural rock formations and for the parks, historic sites and all that. Okay, ni silap ni. Okay. So this is the example of combination between, this is the plan, okay, meaning that curving, corner to the left, corner to the right, corner to the left, and this is the profile, meaning going uphill, downhill, uphill, downhill. So in this coordination, you can see that the horizontal curve is combined with vertical curve in such a way that it does not hide any features along the road. So you can see here. All right, so this is the example lah for this picture. So going up, down, and here is, this is going to the right, going to the left, going to the right. So up, down, up, down. Okay, so you can see the combination here will result in this type of appearance. Smooth appearance, everything is visible. And then you have acceptable coordination. Okay, this is going to the right, going to the left. Okay, and then you have going up and down, up and down. Okay. So in this case, for this diagram here, it is just one large curve, and then the profile is going up and down here like this. So it is still acceptable, no hidden areas. So in this example, you can see this is the plan, and this is the gradient. So it is quite steep over here. So it will result in this type of perspective. So you cannot see what's in front of this vertical curve. Something is hidden. Even worse if you have a junction, okay, just right next, as you reach, that is only visible as you reach the peak, the summit of this curve. Okay, same case for this example here, bad example. So everything is hidden. Something is hidden here. This is, I think this is the even worse lah. Okay. It is the worst case scenario if you have something that looks as if the road is straight, even though you cannot see some part of here, over here. Okay. But as soon as you see reach the peak of the summit here, you can see there's another curve. That is even worse lah. Okay, meaning that you need to take the other curve and then go straight back here. Okay, so these are the things that we need to avoid lah. All right, transition curves, spirals. Okay, this is the technical punya properties lah for the spirals. You have TS, SC, CS, and ST. So this is the PI. PI or IP lah, point of intersection, IP intersection point. Okay, you have super elevation. Super elevation is the tilting of the roadway to help centrifugal force develop as the vehicles goes around the curve. Okay, as you go along this corner here, corner to the left, although this car is on the right side of the road, you're cornering to the left. So the angle here, the tilting of the road, is the super elevation. Okay, why do you need this super elevation? Because when you are traveling on a curve, you'll have centrifugal force, transverse friction force on the tires, and super elevation force. reacting on this car. To make sure that this car is stable and does not tend to oversteer going outward of this curve, you need this super elevation curve. So when the curve is going to the left, the right side will raise. It will lift from the horizontal axis here. How much will it lift? It depends on the value, the angle of this super elevation. And it must be done gradually over a distance without noticeable reduction in speed or safety. Meaning that it has to go in stages. Okay. So this is the frontal diagram from the front of the forces reacting on the car. And so this is A, alpha here is the super elevation, F here is the friction factor, and V is the RV is the radial force. Okay, this is what I mentioned just now lah. Vehicle is forced radially outward by centrifugal force. The F value is depends on which research that you use. Okay, they have plotted lots of lines here. Okay, for our design, we'll use just one F value. I think there is mentioned somewhere in the notes. So it depends on the speed, okay, and what is the side friction. We do not use this diagram for our design. I'll give you the values afterwards. All right. So how do you design the super elevation? Sekejap, saya ambil gula-gula lagi sekejap. Okay. Saya sekarang selalu sakit tekak. Tekak selalu kering. Okay, super elevation transitions. This is a road of a corner. I'll just use the term corner lah, ya. Easier for you to understand. Circular curve lah, the curve actually. A corner going to the right. This is straight segment, which is the run out. On a straight segment, you will have this N. Okay, meaning that on a straight segment, any road, you're going to have a certain percentage of tilt even before you enter the curve. All road must have at least 2.5% here. This is to ensure that rainwater will drain to the sides. Okay, so you need certain percentage here, 2.5 until 3.5 on straight segments. Okay. Here, from the circular curve until this part here, we designate as LE or LDS or LSD, length of super elevation development. Meaning from this point, this angle here, 2.5% normally, will start to move going up. You see this line, going up, going up, going up until point TS, it is flat. And this side here, N maintains until point TS. So the angle here, if it is 2.5 until this point, this is still 2.5. But this side has started to move. Okay, from N, going up, going up, going up. Now it is 0 because it is flat. Okay. From this point, TS to SC, this flat surface will continue to move up until it reach point SC, where the actual circular curve starts. Okay? This part over here is the spiral part. This part is the circular part. So in the spiral part, when they say crown section, it means that this is normal, 2.5, 2.5. I'll just use negative lah, negative 2.5 because it is going down. Okay, negative 2.5 going down here. Here it is 0. So this is negative 2.5. This is also negative 2.5. It does not move on the right hand side. This side is starting to move. So from here 0, it will continue moving until it reach the maximum super elevation value that you use for your design. Normally, we use 6%, 8%, or 10%. From SC over here to point CS over here, the super elevation value maintains. Oh, I forgot to mention from ni. Ni tadi N, this is also N. But at point TS, this side starts to move as well. Until it reaches this point, it becomes, let's say if the super elevation value is 10%, so it becomes 10. Okay? So what it means, SS, TS, and SC. SS is straight to spiral. This segment over here, prior to this spiral, is straight, and this is spiral. This is TS, tangent to spiral. And then the SC is the spiral to curve. TS is curve to spiral. ST is spiral to tangent. And then SS is spiral to straight. Okay. Run off, run out is just the terms that we use in the run technique. For your design, in my opinion it's easier for you to use LDS here. LDS or LSD is the total of this segment, the length of this segment. This segment is divided into 3. 2/3 is run off. This is 2/3, this is 1/3. Okay. When you say, I repeat again bila dia cakap crown section, it means that the cross section is like this. Negative, negative. This is crown section. Level section meaning that it is level. And here is super elevation. Okay, important. This design is selalu salah construction. Construction is wrong. And nobody says anything. And it ends up in the design. Maybe I'll show you. Okay. I wanted to show you one example . Okay, so this is an example in Kajang. So you nampak tak lori ni dengan kereta ni is actually tilting to the left. This is a corner going to the right, but yet this lorry is tilting to the left. This is because right hand side is higher than left hand side, whereas the right design should be left hand side should be higher than the right hand side. Okay, once the road is already constructed, to correct this is very difficult. It's very costly. This is where it must be done correctly the first time. Okay, so this is very dangerous, although it is not very clear in this picture, but this is quite severe actually. Okay, earlier this year, a lorry was traveling on this side of the road. I think he got to be driving very fast lah. And then he crossed over, entering the coming lane here, and hit one car. That car was driven by a father, okay, and then there's his wife and 2 children. Only one of the children survives. Okay, the father and mother pass away, and one of the children passed. Now that boy is an only child. Memang tak ada parents, yatim piatu. We cannot say that it is totally because of this problem, but I'm quite convinced lah. If you are driving too fast here, and you feel that your truck, your lorry is going to spill over to the left, you are going to grab your steering wheel to the right. Because you are too fast, your lorry is going to be crossing over this curb and entering the coming traffic. I think that is what happened. Okay, so nowadays, the mistake is still here, but they have put lots of 2 rows of concrete barriers. Okay, they have put rumble strip. They have put signboards. They have put lights, blinking lights, to make sure that people slow down when entering this curve. Okay, but the mistake in the super elevation is still there. Okay, because they cannot, difficult for them to correct the super elevation. So this is the implication, although seems very simple, super elevation, but the implication is death. Okay, and in this case, we have created one child, yatim piatu, lost his father, lost his mother, and lost his sister. He's a boy lah. Okay. Okay, so to calculate the LDS, this is the formula. You need the N value, normal crossfall, which is normally around 2.5%. Super elevation that you have chosen for your road, like I've said, is either 6%, 8%, or 10%. And then you have the design speed, and 0.025, this is a fixed value for rate of rotation. And then you have LT equals to 2/3 of LSD or LDS lah, LDS. Or you can use this formula. For your project, please use this simpler formula. Okay. All right. Next, we have super elevation development diagram. this is slightly tricky to understand. Although we only have 5 more slides, but I'll take more time explaining this because it is quite important. Okay, you look at these lines. Right hand side, left hand side. This is the center line. Left hand side, right hand side. So this is point from split segment to point SS. You can see right hand side, left hand side. This is negative 0.03, which is 3%. What this means is you are looking at this segment from the side. This is the center line, which is higher than the edge line. Because the percentage here, let's say it is, in this example, is 3%. Negative 3% over here, negative 3% over here. When you are looking from the side over here, you see this line is on top of the edge line. And right hand side and left hand side is on the same line because the gradient is the same until you reach point TS. Okay, at point TS, ni terbalik ni. Right hand side goes up. Okay. Ini saya takut you confuse sikit. Okay. This is diagram for the curve to the left. This diagram is a curve to the right. Okay. I think I'll just put a text box here. This is actually left hand side. Fill. Okay. So this is the curve to the right. Okay. So you can see here, the left hand side has gone up. From here to here, if you look from the side, the left hand side has gone up. The right hand side here, the edge line here, is still on the same place. So here, titik apa tadi? TS kan? TS. This part has gone up. Okay, the left hand side. The right hand side is still maintained. Okay. Lepas tu titik TP. TP over here. Oh, ada satu lagi titik tidak ditunjuk dekat sini. Tangent point. It's the same thing. This flat is continuing to raise. Okay. From here, it continues to raise until this point TP. Right hand side also maintain flat until this point. Okay. At point TP, left hand side continues going up until it reach 6% here, which is the full super elevation. And at point TP, the right hand side start raising, going up. Okay, from negative 3% to negative 6%. So at point SC here, both sides, left hand side and right hand side, has reached full super elevation, which is this part. Okay, it's just that in this diagram it does not show TP point TP kat sini. At point TP, this side still does not move, but this one continues to move up. Beyond TP, this side start to move until it reach full super elevation over here. So this is the one part of the diagram. If you see here, this is one part of the diagram, and then there's another part over here, which means you have something like this. First part, second part. The one that I show you is the first part. If you plot for both sides, first part and second part, you'll get the diagram like this. Okay. All right. So maximum super elevation is between 6% and 10%. Where areas you have climatic conditions that causes slippery surface, you cannot exceed 8%. So it depends on your judgment lah. So generally it should be anywhere, it can be anywhere between 6% and 10%. Okay, design example part, I'll give you a link in your chat segment to a channel, YouTube channel. In that channel, I have uploaded week 1 lecture notes, just introduction kan, short lecture. And then week 2, which is your highway engineering intro. And then week 3. Unfortunately, for week 3, the design part is divided into 12 segments. 12 short segments. So you can go one by one lah. Okay, at that time, I'm doing it in small segments. So I hope it is not a hassle lah for you. Okay, and then I'll upload the most recent lecture in this channel as well afterwards lah. Okay, don't forget to scan your attendance. Okay, so this I have provided a link in your chat. So that's the link to the channel. You can view part 1 to part 12, okay, as a design example. You will need the file from Spectrum, which is design example part 1, design example part 2, and design example part 3 for this exercise. Yep. Yeah, you need that. Okay. Bear in mind, in this example, the scale that I use is 1 to 500. Okay. Whereas for your project, the scale is 1 to 1000 for the topo map. So you can choose to create the radius template accordingly lah. Alright. Okay. So, any questions?
Doctor, I have a question.
Yes.
Can you explain about the slide 72? I
Slide
don't quite understand.
Oh, okay. Slide 72.
Yeah.
Okay. Do you understand this part?
Yeah, a bit.
Okay. This part is half of this diagram.
Okay.
Because our road is connected like so, you entering the curve and then you exit the curve. Upon entering your curve, you will have this diagram. Okay. Right hand side, left hand side at the same level, and then left hand side goes up because it is a curve to the right. And then here, the right hand side goes down because, okay lah, curve to the right lah kan. Okay, right hand side going down. It's like you are extending your hands on your side. It's like you are flying lah. Okay kan? You're flying. Your left hand goes up and then your right hand goes down. Okay, so this is negative, this is positive. So left hand side from negative becomes 0 over here, and then it becomes positive, 6%. Right hand side from negative 3, it goes further down to negative 0.03. So this is only this segment. To complete that diagram, you have to exit this curve, and from this curve, upon exiting, the left hand side will start to go down. Okay, and the right hand side will start to go up. So it means this diagram will be macam mana nak cakap?
Like a mirror, right?
Like a mirror, yes, correct. Okay, it will be like a mirror. So now the left hand side that has gone up, will continue. Okay, this is along the circular curve part, and when it reach SC on the other side, it will go down until 0, until here negative 3. The right hand side as well, it will go further down here, maintain at negative 6, and at this point, TP on the other side, it will start to go up. From negative 3 becomes from negative 6 over here, it becomes negative 3, and then it maintains. Boleh ya?
So how do we differentiate the center line outside edge and inside edge? Thank you.
Center line maintains because it's always in the middle. Outside edge and inside edge. This is the same with right hand side, left hand side lah. If the cornering to the right, left side is the outside edge, right side is the inside edge. So here, outside and inside is at the same level. When it reach here, left hand side goes up, right hand side maintain until TP, and then it goes further down. The easiest way to understand is to use this diagram and just duplicate on the other side as a mirror.
Okay, understood, Doctor. Thank you.
If you have any problems, if you still have difficulty in understanding, you can just contact me by phone. Okay. Anybody lah, because sometimes it's quite difficult to visualize the example here. Okay. Any more questions?
No, Doctor.
Okay. If there's no question, it's already 12:30. So you can watch the video when you are free. Yeah. Okay. If you encountered advertisements or commercials in that channel, I don't know why that happened. I didn't monetize the channel. I just put in the video, and suddenly when I try to watch using my different account, there's an ad. If you have any idea how to remove the ad, please inform me, because I haven't picked anything that to include ads or anything on my video. It's non-monetary. Okay. Nothing else, eh? Okay, if there is nothing else, I think I'll stop the class here. Okay, happy holidays for those who are celebrating Deepavali tomorrow. I hope you have a enjoyable time with your families. And for everyone else, and everybody lah, bukan everyone else, everybody need to be, please stay safe. Thank you very much.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor. Thank you, Doctor.
Thank you.
Thank you, Doctor. Welcome, everybody. Welcome.